Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Good evening to all viewers and also attendees. First of all, thank you MPC Chemical Productivity MPC Chemical Productivity Nexus for organizing inviting me to moderate after lunch biasalah. And inviting me to moderate this webinar. And also thank you all the attendees or participants, the viewers for making time to attend this interesting webinar on topic that I consider very good for sharing. Yeah. My name is Riwayat and I'm the moderator for today. To accommodate the majority of the audiences, this webinar will be moderated in both language, bilingual, English and Bahasa Malaysia. Today's webinar session is one of many series organized by MPC. And the title or the subject of this talk today is Improving Chemical Plant Productivity and Safety through Lean Plant Product Movement. Right? This morning, actually, we just had one webinar organized by Chemical Productivity Nexus as well, titled Application for Effective and Efficient for Manufacturing in Chemical Plant. The talk was given by the same speaker. I will introduce the speaker afterward. That webinar, to me, it was a good introduction and overview that was given by the speaker for the chemical industry. Yeah. Okay. Before we proceed further, before we ask the speaker to share and start his presentation, let's clear a few housekeeping items first. Yeah. In order to number one, in order to to ensure smooth flow of this webinar, all participants will be put on mute. Just in case if you have any questions, there is question section for you that you can utilize in the control panel in your device. Yeah, you can go to that control panel and put your question there. Yeah, the question since I said that this is in bilingual, so the question can be posted in both languages, Malay and English. And depending on the situation, the questions will be either posed to the speaker during the presentation, or we will keep them until the end of the presentation. So it depends. It depends on the situation. Yeah, it depends on the time. It depends on the type of question that you have. If it's relevant to that particular subject of presentation, we will be asking that question. Otherwise, we'll be keeping it at the end of the presentation. If the time doesn't permit for all the questions to be answered by the presenter, we may choose to respond them by email or WhatsApp. Yeah, you can leave your email, and we will try to get back to you to answer the question. Okay, all right. Now with us today, we are very fortunate to have a very distinguished individual who is very knowledgeable and intimate with the MPC Chemical Productivity Nexus, and he will share his knowledge and insight on the title Improving Chemical Plant Productivity and Safety Through Lean Plant Product Movement. Let me introduce our speaker for this webinar. His name is Dr. Adli Ferdin Ramli. He is a fellow of Industrial Engineering Operation Management Society International, or in short IEOM, which is based in Michigan in United States. He has been an auditor, assessor, trainer, and consultant for operational excellence since 2001. His experience is in the automotive field, where he focuses on operational efficiency through the elimination of waste, right? Utilizing VSM in the lean management techniques. Yeah? He has audited and assessed hundreds of organizations, including giant plant and also the small plant. Yeah, Dr. Adli is the founder and the director of EFR certification. This organization is an international certification body. He conducts a variety of high-impact training and workshops in the areas of workplace improvement, waste reduction, problem-solving techniques, and so on and so forth. Because of this, his extensive exposure in various management systems, he actively involved in the areas of auditing, evaluating, assessing, consulting, and also training in business excellence, and also operational excellence, lean management system, ISO 9001, IATF 16949, ISO 14001 for the environmental, occupational health, ISO 45001, business continuity, and in so many, to all level of organization, including SMEs and also MNCs. Okay, not to further delay, I would like to invite Dr. Adli to share with us on the topic of improving chemical plant productivity and safety through lean plant product movement. Dr. Adli, please proceed with your sharing with us. I think you're on mute. Are you on mute?
Okay. Sorry, yeah.
All
okay,
right.
thank you. All right, so thank you, Riwayat. So we meet again after a short break this morning, this afternoon, the session. Now we'll be focusing on the movement waste, okay, or what we call pembaziran pergerakan. Right. I like to thanks also to the participants that joined this afternoon webinar. So Assalamualaikum, and hope you have a very good day. Okay, and this words movement is quite interesting. Okay, because now we are under movement control. So now we are under movement control. Okay, so we're going to talk about the movement waste. A lot of you now WFH working from home. Some of you have limited times working at the workplace. Okay, 3 days maybe at home, 3 days at the workplace. Okay, so this movement control is something like just nice. The topic that we're going to discuss, especially today, right? On the continuity, basically for those who joined us this afternoon at 11:45 just now, I did mention one of the ways, one of the most common ways, is move. Another one is, of course, is about storage. Right, this is the main one. Of course, after that we have the 7 kind of ways. You use worm pit. Some people use downtime. Cow team, short form. So either is cow team, downtime, and so on. Inside there, there is movement waste. Either you use word transport, either you use word conveyance, and then a motion, either whatever you use words, it's actually is a movement waste. Okay, so on the content for today is basically we going to cover about movement in chemical plant and what is the common issue that face in the chemical plant. Why there's so many movement? Why it's so dangerous? Because based on my experience, when we work in the chemical plant, so there's so many forklift here and there, and then there's a truck, there's a tanker all around. And then the pipes is if everywhere. There's overhead. Sometimes it's at the bottom. So there's a lot of product movement. In which some of them have a high pressure. Some of them is very corrosive. And hazardous chemical. In chemical plant, some of it is hot. There is a steam around. So when we work in chemical plant, Okay, we can sense about the hazard and the safety in the chemical plant. So what is the issue? If we have a lot of movement, of course, there will be a lot of issue. So the best is, okay, if we can eliminate, okay, some of unnecessary, which is sometimes we use word avoidable, which is we can avoid that movement. Okay, why we should have that movement in the first place? So if we can eliminate, so we will try to eliminate that. Okay, or if the plant is already there, okay, the investment, millions of dollars has been invested to build the plant. Okay, so maybe we can look out. Okay, there is an opportunity for us to minimize some of the movement. Okay, so for that purpose, I will share one of the topic here is about what is the ideal layout for the chemical plant. Okay, where should be the entrance? Where should be the trucks or the tanker that should come in? Where should be the pedestrian walk? Okay, so what is the best layout? So I will share some. Okay, because most of the plant that I visit, okay, the layout is there. Not much I can do, but I can throw out the ideas. Okay, about this ideal manufacturing layout. Okay, that's first sharing. Second one, that is I share in this limited time. Basically, there's one project that easily reduce, okay, few kilometers of movements of the product. Okay, so there's one project in the chemical plant. Okay, the chemical plant is in Malacca. It's just changing a simple piping and layout. Okay, we eliminate almost 70% of the forklift movement. Okay, and also we minimize, okay, some of the movement of the people there. Okay, so there's a content here, okay, which is what is the main issue, what is the ideal manufacturing layout, and kaizen that's been implemented on layout improvements. Okay, so you're ready. So let's move to the first topic about issue.
Okay, Dr. Adli, just to interrupt a bit for the audience. Those who would like to download the slides, the slides just has been uploaded to the what do you call? You can see that in your control panel. If you wish to download the slide, you can just click and download the slide so that you can maybe it's for your future reference, or you want to refer it now while Dr. Adli is presenting. So is there? Yeah, the handout is has been uploaded. You can download them. Yeah. Okay. Thanks. Sorry, Dr. Adli, for the interruption. I just want to share.
Can. I also just saw the handout just pop up.
Yeah.
Okay, so you can download that. Okay, so what is the product movement in the chemical plant? Right. First of all is of course, the movement of the raw material. Okay, so this raw material it can be in the liquid form. Okay, some of it is liquid form. Okay, some of it maybe in the powder form. Some of it maybe in the gaseous form. Okay, so this raw material, okay, the packaging can be in the drums. Okay, some of it maybe in the packaging, carton box packaging, and so on. Okay, so of course, when we want to start any chemical reaction process, any chemical manufacturing, we need the raw material. Okay, so of course, in terms of mode of movement, later I will share. Some of it maybe is manual, some of it is by pipe, pump, tanks, and so on. Okay, and then the second types is WIP. Okay, work in progress. So basically, work in progress is the intermediate in chemical industry or a chemical plant. Okay, normally the first process is about preparation of master batch, preparation of the catalyst. So that is first part. Okay, and then we keep before it's going to be charged to the chemical reactors, okay, or the blending machine, or agitator or refinery. Okay, so after it's complete, normally when we have the big reactors, these parts or this product, we call it the base product. So this base product is maybe going to the blending, for example, to have some coloration, to put some additive. Okay, that is the work in progress movement that commonly have in the chemical plant. Okay, and then the third movement is about the finished good movement, right? So this finished good, either in the drum or some of the products, maybe in the tanker, some of it is maybe in the bag. For example, a plastic resin, okay, is in the bag. Okay, maybe they have 1 ton ISO bag, okay, or they have 25 kilo bags. That's quite common, okay, in industry. Okay, so how they move this product? So the movement, normally when we have a liquid and gases type, okay, we're going to use tanker. But those who are quite close to the port, for example, in Johor, we have Tanjung Langsat port, Terminal 1, we have Johor port. Some of the liquid, the chemical actually is transferred by using the pipe. Okay, so there's a lot of pipes near the ports. Means it's transferring is by using the pipes. Okay, that's for those gaseous and liquid types. And then we have, for example, we have a container. Okay, this is normally for solid type. Okay, and some of the smaller version maybe in pail, dalam baldi. Okay, in pail, some of it in bag, people using the manual handling. And to support with manual handling, normally they have the forklift to bring the parts around. Okay, so we have to analyze all this movement. Okay, so if we have the plan layout, first of all, okay, what we need is to study, okay, where is the movement of the tanker? Okay, where is the movement of the lorry, trucks? Where is the movement of the forklift? Where is the movement of the pipes? Okay, and also where is the movement of the manual handling? Okay, so this is important analysis. Okay, because if we want to eliminate, all this, or if we want to reduce this, we have to study this. Okay, why we have to eliminate or why we have to reduce this? Okay, because movement, like I mentioned earlier, either during the first webinar, okay, is first of all is about the safety. The more movement of the product, the more potential of the product going to be released, accidental release, or potentially going to have spillage, or potentially to have a contact with the human, either inhale or splash. So the more movement, the more potential safety issue in the chemical plant, right? And then, of course, the people safety when handling the chemical product. Okay, there is a potential that accidentally may be hit by the trucks, by the tanker. I just don't want to show some of the video. Maybe you can download a lot of video of forklift accidents, truck accidents, while loading, unloading of the finished good or the raw material. Okay, so there's so many accidents. Okay, on transportation, on the movement. So if we can reduce this, okay, of course it will help to lead into the more safer and more productive chemical plant or organization. Okay, so why there is a lot of movement? Of course, it's non-value added. Okay, most of the reason we find out is the plant design. Okay, I'm not promoting the IE, industrial engineering, even though I'm one of the fellow in the industrial engineering. Okay, but most of the design is designed by the maybe by the chemists, by the financial people. So without looking into how to minimize, or if necessary, we remove or eliminate some of the product movement if necessary. Okay, so that's why when we visit the chemical plant, there is a lot of unnecessary movement that actually can be avoided if the plant design has been designed properly. Okay, another example, I always ask, why your tank farm you always put at the end, okay, after 1 or 2 kilometers, maybe less than 1 kilometer, the end of the plant. Okay, some of them say, okay, because of the safety. Okay, if it's too near to the plant, okay, they can cause explosion, and then can cause another big issue, catastrophe issue. Okay, but I agree. Okay, but why is so far? Is there any study if the explosion can be more than 500? Okay, 500 meter, or is it just 200 meter, or maybe 100 meter? Okay, why you didn't put near to the front, the entrance, so it can minimize the tanker movement inside your plant? Okay, why your entrance is too far from the tank farm? Okay, so that's a question that I ask. At the end, they cannot answer. Okay, why they put that? Okay, I'm not saying that they try to make the project more expensive. Okay, so that it's look like worth of investment or what. Okay, but I can say the study of the plant design is one of the main issues. Okay.
Just a question, Dudley.
Yes, yeah, betul. Please.
Okay. Just I don't know. I'm not very familiar with the chemical industry or chemical plant. Just based on your work experience, is it typical for the chemical plant or chemical factory to use AGV, the automated guided vehicle? You know, the in electronics, there are a lot of AGV that is being used, so that you don't depend on human. You just program, and then the vehicle will be guided to specific location where you want it to be. Dalam chemical industry, is it typical also that they use AGV?
It's hardly seen lah. If in Malaysia, I never seen it yet. Okay, but of course in automotive industry, yes, I already see some of the clips in Porsche factories and so on. But
yeah,
in
automotive
chemical,
definitely, yeah, you're right.
but in chemical so far, no. I only see maybe most of it is just a pipe. They have a lot of pipe overhead down there and pump out this chemical. Okay, interesting. Okay, actually there is area that they can deploy this AGV. Actually, there's a potential on this minimize the people safety by not handling the chemical, by using the robot instead.
Exactly. Yeah.
So it is good potential. Okay, but before that, in 2nd of December, we're going to have the Industry 4.0, okay, which is talking about we're going to put some Internet of Things, maybe using some AGV as well. Okay, but of course, there is something that we need to look first before we deploy them, which is most of my observation in the organization. Okay, they have a lot of double and triple handling, which is unnecessary. Okay, but before you deploy AGV, okay, you lean your movement first, and then identify where is the necessary area that we have to put AGV. Okay, that's why we need to do some readiness assessment on process readiness. Okay, rather than we say, okay, this one have to do AGV, this one AGV, but actually the movement is not necessary. The movement can be reduced or eliminated straight away. So instead of putting AGV, you put more investment. So at the end, actually, you still have the waste inside your process.
True. Unless it comes to the point that you cannot avoid that, and then you have to get the transportation, and then only you put the AGV. I fully agree with you. Thanks, Doctor.
So Thanks for the insight. Okay, so to make it more productive, right? And when we want to do this all, okay, so a simple methodology, which is a spaghetti diagram, okay, in which I will share a little bit, okay, to study whether is this necessary or is it unnecessary, is it avoidable or is it unavoidable movement. So if it's avoidable, then okay, better we eliminate that straight away instead of making additional movement or putting technology on the unnecessary movement. Okay, so in the 7 kind of ways, okay, transportations is about product movements, okay, while the motion is basically talk about people movement. All right, so what we're trying to do is we try to do both. When we do study, we study the product movement because when there is a less product movement, then there will be a less people movement. Okay, but if there is lot of product movement, there will be a lot of people movement as well. Okay, so normally my first study, okay, when I go to the plant, okay, I ask about the product movement first, right? So from there, we're going to identify where is the people movement is required. Right, so let's look on the next section, okay, which is some ideas, okay, on how to eliminate or reduce movement by having the most ideal, okay, or the most practicable main factory layout. Okay, so I just share one example inside here. Okay, this is some of the typical what we call typical chemical plant, okay, which is we have the plant area, okay, which is the plant area is normally where the reactor, okay, maybe the reactor is sit here, and maybe this is the blending machine, okay, maybe here is a mixing machine, all right, and then they have lab, quite common, right? Have lab, and then for plant normally they have workshop, they have store. Right? This is normally referring to finished goods store, FG. Okay, and then we have the tank farm. Okay, let's say this more on like liquid or gaseous type of the chemical plant. Okay, so let's say this is the main road, right? Of main road we consider as like public road. So this is a public road. All right. So the question is, first of all, okay, where is the entrance? Okay, or where is the exit gate? Okay, so let's say I put example the entrance is here. Okay, so there is some security guard right here. Okay, this is the public road. Okay, the first question. You want to move the what we call the raw material. Okay, so the trucks will enter here. Okay, so maybe they have weighing bridge, quite common in chemical plant. They have weighing bridge, so they have to weigh all the chemical or the raw material they're going to. Okay, and then the truck driver going to drive through this road. Okay, until it come to the pump station, so where it can pump out the material. Okay, so this is the first spaghetti that we can draw. Okay, after that, okay, the truck driver maybe have to U-turn back, empty the tank, and then you have to go out through this entrance. Maybe you have to stop for weighing bridge again. Okay, there's a weighing bridge here. Okay, saying that you already unload all the chemical and then move out. Okay, so that's on the raw material parts. Okay, and then all this chemical going to be if using a control Internet of Things, the control panels and control rooms. Maybe all this going to be pumped straight away to the plant. Okay, which is we can see again this is a movement of the chemical to the plant area. Okay, so looking on this, we can analyze this is less spaghetti because it's quite short. It's also trying to support plant 1 and plant 2. Okay, but after complete, maybe we have to move to the store, in which from here we can see there's a block here, so no choice. This part have to go through this path to go to the store. How about plant 1? Okay, maybe some part of plant 1 is going to this pipe, okay, and then maybe go to here. Okay, but some of the part maybe it's finished good. Then you have to go out here to go to the store. Okay, so this is about the spaghetti. We call it spaghetti diagram. Okay, so it's look like it's not really nicely arranged in terms of, for example, raw material. Okay, it's quite far, the trucks. Okay, example, when there is a people that have to walk around here, because they have a lab right here, there's a potential people going to walk around. There's a workshop here, there's plant facilities, there's a canteen. Okay, so all these people have to walk around. Maybe they have to walk through the truck lane. This is the tanker or the truck lanes. Okay, it's going to have a safety issue or safety hazard. So if can, okay, all this we want to centralize it to make sure that people, of course, there's plant utilities, that people going to enter through here. Okay, maybe you have to go to change house, go to the plant. Some of them have to go to laboratory, some have to go to the plant using this road. Okay, so there is a lot of movement as well. Okay, the red one is a product movement. The yellow one is actually the people movement. Okay, so look like we need to do something with this layout. If can, if cannot, then we have to think back. Okay, maybe we have to relocate the entrance, because to relocate the tank farm is going to be expensive. To relocate store is not that expensive. Maybe it's feasible. Okay, to relocate canteen, chain house, workshop, plant utilities, maybe it's more feasible. Okay, so how can we do that? But before we do that, for the next project, okay, we talk about the new plant first. Right, so let's say we want to design a new plant. Okay, what is the best layout that we can design? Okay, so everybody is there. Haji, ada
Still
sana
around?
Haji? Alright,
Yeah.
okay. Hopefully I'm not talk alone. Anyway, it's okay because it's recorded.
The spaghetti really looks like it's a real spaghetti now. Yeah, it looks very busy. Yeah.
Yes, yes. Okay. It's not yet put a proper one. Maybe they have product A, product B, product C.
Yeah,
and
there's
then
gonna be a lot. Yeah.
They're more like bolognese already.
Yeah.
Right. Okay. So how to minimize that? There is techniques in Lean. Okay, we have this what we call a common U shape, we call it a common U shape. Okay, why we recommend the U shape? Okay, first of all, The most important one is how big is your plant. Okay? If you have a single entry, that is better. Why? Because when you have a single entry like this, okay, you only have one guard house. If you have 3 or 4 entry point, it means that you need more guard house. Okay, so let's say you only have one. Okay, so this guard house can be like administration, okay, for weighing the material that in, weighing the finished good that out. Okay, also look on the what we call the people movement. Okay, and then maybe just have the control center here with the CCTV. So you just have CCTV in here. So we no need to have so many guard posts in which we can minimize as well. Okay, the cost of employing more guards into the chemical plant. Okay, so recommendation, if you can have single entry, that is the best. If you have 2 or 3 entry, there is a potential for improvement that can be implemented. Okay, so where should we put the tank farm? Let's say you have tank farm plus the raw material warehouse. Okay, so first of all, look on the okay, so first look on the entry point first. Okay, so this is the entry point. Okay, so the best, if we can, okay, to put the what we call tank farm. Okay, so this is a tank farm. Okay, let's say if there is a warehouse that is required, okay, so you should put around this area as well. Okay, the best if we can nearer to the production line, but because of normally bomber requirement and so on, we need the access central bomber and so on. We are going to have okay what we call the service road. This is a service road. Okay, this depend on because chemical plant normally is have the bomber requirement and so on. Okay, so we have access here, and then if possible, okay, so the material, okay, sorry, okay, okay, so the material should be pumped straight away to here. Okay, or if we can nearby, if they need the warehouse or whatsoever, okay, you can put here unloading the activity. Okay, so if you put the tank farm at behind, you can imagine okay how far the truck driver have to drive, okay, and then how to monitor the unloading activity. There's a people movement have to go here. Okay, so if can, okay, all the raw material, okay, should be nearby to the entrance, right? Okay, and then where we should put our finished good, right? So this is the raw material. So this raw material. And then our finished good, okay, if necessary, it should be around here. All right. So if the product actually come from process number 1 and number 2, then I will propose the finished good warehouse should be in the middle. Okay, because if the product from number 1 go to here, I consider it's quite far also. So if if the product is come from 1 or from 2 to the warehouse straight away, then we can put in the middle. If the process is really like a U-shaped process, then the warehouse can be put here. Okay, I prefer in the middle. Why? Because the trucks here, okay, can enter to this side safely, okay, to collect the finished good. So this is the product movement. Okay, because once it's pumped out, okay, and then the you go to the process, let's say you have to go to process 1, process 2, process 3, 4, 5, 6. Okay, the movement is according to the flow of the product. So we don't need to pump from 1, have to go to process number 2. For example, is here. You need a pipe here. After that, we have to go to process number 3. We have to pump back here. Actually, is according to the flow of the process. Example number 1 is mixing. Number 2 is chemical reaction, the reactor. Number 3 is blending. Number 4 is we put some compounding. So after compounding, maybe we do packing. So go packing and then it's finished good. So if we follow the product flow, instead of we have to if you didn't follow the product flow, what happened is you need maybe forklift movement here. Maybe we need some pipes. We need more pipes, and then it become more spaghetti. Right. So the first rule, okay, identify where is your raw material. Okay. Secondly, identify your finished good. And number 3, follow your product flow. This will be the ideal layout for the movement. Okay. So how about the people? So if we identify, we put our workshop in the middle. We put canteen in the middle. We put the changing room maybe in here when they start. So people when enter, okay, of course there's zebra crossing. Okay, if have overhead, it's better. Means there's some truck maybe have to drive through here. Okay, so there's a movement, and maybe the car parking maybe is just around here. Okay, so they can enter to the work, and then they go changing room, and then they can go to their works. Okay, so it's more centralized. Okay, and then it's shorter for them to walk to their plant. Okay, if not, they have a lot of hiding place. Okay, if you look on the previous one, okay, actually there is a lot of the hiding place where they can curi-curi tidur, curi-curi tengok Facebook. So with this, we have more center. The office is also nearby here. The control room also in the middle. So you are controlling your people or confine them in the middle of the factory, and then it's quite short for them to move. Okay, this is ideal, and if possible, if we can try to design this. Okay, so that's why some of the client that plan to set up their new plan. So I will highlight the main issue. Okay, and then try to follow the product flow and then identify where is the people movement. Okay, so that's sharing on ideal. So riwayat and things that
I think that looks great. Yeah.
Okay, so we move to the next one. Right. And then for the next one, okay, I just want to share about one of the kaizen. I cannot move their tank farm. I cannot move their warehouse, their reactor, and so on. Okay, so we come in, see whatever is possible, see where is the people movement, product movement, whatever that is necessary. Okay, and then we try to do kaizen for this company. Okay, first of all, the process, okay, is basically they have a reactor, and then after that, after the chemical complete the reaction, and then they have to dilute it. Okay, and then they do the blending. After blending, the product is going to pump into the drum. Okay, so the forklift actually have to move near the reactor. Okay, the forklift also have to go to the dilution, blending, okay, to move the drum. Okay, this is when I enter to this plant, I see, there's forklift near to reactor. What happened if suddenly forklift accidentally hit the reactor? What going to happen to the plant? So I saw, wow, how come the forklift is inside the plant? So that's my first observation. There is something that I have to highlight. when I visit this company. Okay, and then I saw when the product complete blending, okay, there's a lot of forklift movement inside the plant because they have to pump to the drum. Once they have to bring the empty drum, they have to take out the drum with the product. Okay, so I found that there's a lot of movement inside the plant, so we need to do something with it. Okay, so I asked them, okay, can you give me the plan layout? Okay, they said they don't have a real one. So what happened is, okay, I just draw a quick one in which we identify, okay, actually there is the dilution tank. This is D3. Okay, you can see here, okay, there is the reactor, okay, around here, there's a reactor. Okay, and then there is a movement of forklift because after they dilute and the dilution is happen around here. Okay, so they have to pump it into the drum. Okay, so they have one of the pump, okay, which is they have one in PM3. Okay, this PM3 is the pump 3. Okay, in which they have to pump out the product into the drums. Okay, put on the pallets. After put on a pallet, they have to send to the finished good warehouse, which is outside. Okay, but before they can pump, okay, that is the what we call empty drum. Okay, they need to bring this empty drum. Okay, this is all empty drum. They have to bring through here, right? They have to go down here, go inside. Right? Normally they have two forklift. One bring the finished good part, one bring the empty drum. So they arrange all that in here. Okay, so this is all the empty drum they arrange so that the operator can pump. Okay, okay, and then they also have pump 4 and pump 5 here, another packing line. Okay, so there is a packing line. Okay, means PM3 is the pump 3. They have packing line here, and then they have pump 4 for packing line. Packing line for lot 3 and 4, and then lot 5, and so on. Okay, so I say I don't want forklift in this area. I don't want this. Okay, it's dangerous. You have dilution tank, you have reactor. Actually, they have 2 reactor in here. Okay, there's a lot of movement, and then people also walk here to take sample. So I told the plant manager, okay, if necessary, we want to remove all these drumming activities. Bukan main drum band lah, okay, drumming activities, packing activities, to outside of this. Okay, if necessary, all will be done around here, outside. Okay, so after a few discussion from the team, what we do is I just throw out something. Okay, your pump 3, okay, why you put inside near to the dilution tank? Okay, can we move this pump to outside? Okay, but of course there is a cost of movement, which is they need to install the pipe. They need to install the pipe. Okay, from this dilution 3 to pump 3. So there's some pipes need to be here. Okay, so that there will be no forklift movement around here. Okay, and then there is a pump number 4 in here and pump number 5 in here. Okay, originally, but I found it is not really organized because we have to put all the empty drum here. You have to put all empty and finished goods. Still forklift have to take, bring back to the finished good. Okay, and then the forklift have to take from the drum and then put here. Okay, and then they have to send to the drum to here. Okay, so many movement as well. So I told them, can we arrange? Okay, the pump 4, okay, for the drumming process of packing, from here we move to here, And then pump 5, we move to here. Okay, why? First of all, when you pump out, when it's complete, the finished good will be here. The finished good will be here. The finished good will be here. This will be only forklift route out and in to take the parts to the store. This is finished good store outside. Okay, so they will bring the drum. Okay, they will bring the drum. Only the forklift will be placed around this area. Okay, but how about empty? I told them empty is light. It's not like the finished good. Finished good is going to be heavy because the product inside here. But this drum, this empty drum, actually is light. Okay, and then we can have a simple conveyor. Okay, rolling conveyor. Put down here, move to here, and then we will use gravity. I told them no need to use electricity, use a gravity, the drum, put here, and then it's queue here. We pump the drum, the product into here. Okay, and then when it's finished, they put a pallet, so the forklift go there. Same with the pump number 2, okay, they have some conveyor, okay, to move that. Okay, so from there, the movement of forklift all around the factory, all around factory is no more, it's only inside here only. So the kaizen is quite simple. Okay, of course they need some investment on the pipe. They ask the quotation. Okay, so this project basically told them, okay, we do some study, okay, based on the transport or range of empty drum and so on. So this is about the movement of the forklift, about 8,400 feet. Okay, after we do that, we can reduce to 2,320 feet. Okay, for the pump 4, okay, of course, almost 78%. Pump 5, 77% reduction. Okay, so this is based on the calculation that we made. Then I told them, okay, let's get the quotation on how much is the cost, okay, of the pipe. Okay, so they get the contractors, okay, to rearrange the back. Okay, the pipe system, okay, is investment about 15,000 ringgit only. Okay, so this is where the pump 3, this is the pump 3, this is pump 4, and then this is pump 5. Okay, this is the way out, okay, to the warehouse. Okay, so it's a 15,000 investment. Then I present to the management. Okay, present to the management. Okay, of course, this is 2016 project. We can save. Okay, number 1, what is the intangible save that we can make? Okay, first of all is the driver costs. Okay, and then the diesel for the forklift, and then forklift maintenance, and then some intangible benefit of safety and so on. So on few months, actually, they already ROI for that 15,000. 15,000 ringgit investment on rearrange the pipe. Okay, so it's success. Okay, it's run the operation with that. Of course, there is a feature which is they keep too many empty drum, which is I say, okay, we better control using GIT system. Okay, so that you have less warehouse for your empty drum. And then drum preparation, because the conveyor is not yet get the quotation to bring the empty drum to the pipe. Okay, so currently they still use manual. So I told them this will be a future project, get the quotation, okay, and have the roller conveyor to fit the drum. Okay, and then of course on their finished good, I found there is a opportunity for improvement as well. Okay, because the forklifts have to be drive quite far to load to the container areas. Okay, there's a lot of pallet damage. Okay, and also the raw material of maintenance and pop-up. Also, they have a lot of movement as well. So this is a future project. I told them when you have budget, they will be nice, okay, if the company can implement the movement, and then you can have a safety and more productive. Okay, so this okay, my final parting line. Okay, but before that, if you have any question, you can interrupt, no problem. Okay, my parting line, final one is basically, if you have less movement, of course, you can be more safe, okay, and then you can be more productive. Okay, you can stop too busy, looking too busy on the unnecessary movement. So I leave to IR Riwayat. Okay, I have to wrap up or to have some more discussion on this. Okay, IR Riwayat.
Yeah, okay, great, Dr. Adli. I think you have shared a lot of good hands-on experience, a real life example, which is I think the audience would benefit from this a lot. Okay, we are coming towards the end, but before that, I would like to see whether there's any question. There's one question here. How come I see this very small? Never mind. The person who asked this question is Miss or Mrs. Atia. So the question is there any possibility of leaking if using pipe, especially installed at the upper areas? I think there's some typo error at the upper areas. So that was the question. No, wait. No, that is somehow it doesn't come out good in my computer. I'll try again. So that's the question. Is there any possibility of leaking? Okay, now I can see it. Of leaking if using pipe, especially installed at the upper areas. That's a question from Miss Atia.
Okay. Thank you, Ms. Atia, for the question. Okay, if we visit chemical plant, even if we visit Tanjung Langsat port or we go to the Port Klang area, okay, there's a lot of overhead pipes. And this pipe is actually need to be approved by the engineer, like IR Riwayat, maybe can sign it out. The design, okay, it must be sustained, depend on the chemicals and that is transport using the pipes. So if it transport the corrosive, they have type of pipes that can be used, type of the fitting they're going to be used. And if it's the type of hot, for example, maybe they have some insulation is required, and there is an inspection ongoing to ensure there is no leakage of the product when transferring using the pipes. Okay, and pipe is one of the common. Okay, why it can reduce the movement of the tanker, for example, that use a driver. Okay, and then the pipes can charge charge the chemical straight away to reactor. We can use the control room. Okay, so it's minimize people interaction. But if you use forklift, you use tank, manual pump, and so on. Okay, it's more hazardous. Okay, even in the food industry, for example, I visit Azad's chili sauce and so on. I say some of your material you should put in the hopper or you should put in the tank. Then you can pump it so you have less people movement. But of course, you need a proper piping system to prevent the leakage. And I prefer is on overhead because we can see the abnormal instead on the ground. Okay, because on the ground, sometimes the leakage is hidden in the gravel and the tank farm. Normally put gravel and so on because people didn't see it. So they see it, they just keep their eyes closed. So the spillage or the leakage is not going to be entertained or somebody going to check that. Okay, so pipes actually is one of the solution to minimize the movement. Of course, the plant layout is important. If no, what happens? You're going to have too many pipeline in your plant, right? Okay, thank you, Atira. Thank you, everyone. So maybe
okay. Another question from Yet Mi Tan. Miss Yet Mi Tan, I'm just guessing it's Miss or a person named by the name of Yet Mi Tan. I'm not sure whether it's male or female. Sounds like female. The question is, hi, how about cleaning with overhead pipes? So you have the overhead pipes. What about doing the cleaning and stuff like that?
Okay, so normally they have ada yang panggil dia anak babi but it's not so nice. They call it piggy, pigging. Okay, so the pigging is like torpedo. Okay, so this torpedo is going to be pumped inside the pipes to clean the pipes. So it's different size of pipe. And it's normally going to be done in chemical plant like JKK. On if your chemical is.
There's a breakup, Dr. Adley, from your explanation. Could you repeat that? Hello, I think we lost Dr. Adley. I think let me text him. Hello. Hello. Okay, I don't know whether I'm the one that's having problem or Dr. Adley is. Can a participant say yes if you can hear me? Just write in the chat column. Can you hear me? Okay. I can be heard. Yeah. Okay. People can hear me. So I think we just give maybe 1 or 2 minutes to Dr. Adley to come back. Yeah. Let me call him. Assalamualaikum, Chief. We lost you. Okay. Okay. So you are having issue with that, yeah? Okay, never mind. I close first. Maybe we just take this question and we answer them via email or whatever lah. Huh? Ada two more question actually. Yeah. Okay. Please. Then okay. Okay. Please. Yeah. Okay. All right. All right. Okay. Okay. It seems to be that there's a problem with the connection. Dr. Adley will try to join back. We'll wait. We give a minute. He said that if it cannot be done, then maybe we have to close. And I've requested him to answer the question for those who ask, yeah, we will try to email to you. Okay, we'll wait for 1 minute. Anyhow, I think just a heads up, yeah. There'll be a few more webinar organized by MPC CPN, which is Chemical Productivity Nexus. One or two will be on the 30th of November, morning and afternoon. There'll be, I can't remember, one or two that is going to be on the 2nd of December. So just be on the lookout, yeah. There will be 2 more seminars. And if you are interested to ask a question, you want to ask the same, you can ask the same question again during the 30th if you have the time. Otherwise, we'll try to get Dr. Adli to respond to you by email. Okay, I think now time now is close to 4:10, yeah, 4:10 p.m. I think let's conclude this session. I think Dr. Adli also is he coming in? Yeah, he's back. Okay.
Yeah, I'm coming. Sorry.
Yeah, okay. Okay, Dr. Adli, the question.
About the cleaning is answer, is it? Using pigging?
Yeah, the cleaning is okay. And there's one more question. Please let us know good location for chemical discharge points.
Good location discharge point to charge to the reactor or for the finished good? Okay, because I can answer both.
The question
because they're
this
charging.
question is from, let me see. The person is not there anymore.
Okay, but anyway, it's okay. I can just share my insight. It's going to be recorded here anyway. Okay, discharging, okay, because charging is normally we load the raw material to the reactor or to the blending tank and so on. Okay, discharge means we want to send for the packing and so on. Okay, so the best is we try to find the place where is nearer to the next process. Okay, if it's nearer to the next process, let's say it's discharge of the reaction process, is process 2. So if possible, the discharging should be near to the process 3. Okay, and then you're going to have less pipe, less forklift movement, because you can directly go to the, for example, like my case just now is dilution tank. So your dilution tank should be beside the reactor. Okay, or if it finish good, is where is your container going to wait for the product? If it nearby to that area, that's even better. You will have less movement. All right. So that's the third question. So the last one.
That's it from the question. That's all I see from the question panel here. Yeah, okay. One from Miss Amira, then Tan Yitmi, and also there's this question. I don't seem to be able to get his or her name on this one. Okay, I think that's about it, Dr. Adli. And
yes. On the 30th, we can talk about TPM.
right.
More on the plant maintenance and so on. Okay, so if you all can join, that would be nice.
Yeah, okay. Yeah, good. So like I said, it has been very insightful. The sharing that you have is a hands-on experience and a real-life situation, so which is very good. And I would like to thank Dr. Adli, yeah, for his valuable knowledge that he shared with us today. And also, not to forget, I would like to thank you also MPC for the tireless effort to promote the knowledge sharing and being a great organizer, yeah, for the webinar. And to all the individuals who has been in this webinar, yeah, like what Dr. Adli said, there will be more coming up on the 30th. So please be on the lookout. 30th of November, there will be 2, morning and afternoon. and I believe morning and afternoon, right, Dr. Adli?
Yes, yeah. So one
Okay,
is
and
TPM and another one is assessment of TPM.
all right. And on the second will be 1 or 2?
Only one session on the
Oh.
IR 4.0 process
All
readiness.
right. So if you are interested in the TPM and IR 4.0, you please be on the lookout for the. We will share the poster about the webinar. Yeah. So at any rate, thank you again for all. Stay safe, stay at home. If you don't have to go out, stay healthy. But however, let's continue to be productive. Yeah. And keep our
minimize movement, be productive.
right, right, and keep our knowledge and learning and mind expanding. Yeah, to continue to sharpen our mind. Thank you very much all. And lastly, I would like to say wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi. Thank you very much.